students, let's continue with our explanation. So here, as I told you, activity 6.1 to 6.5 is not needed, okay, for your exam. So straight away we will move to activity 6.6, but 6.1 to 6.5 you just go through in your textbook. Whatever I explained, okay, that is only there. So you just go through in your textbooks, okay, then you will understand. But it is not going to come for your exam. But this activity you write in your copy because this is important, okay. What is the aim? To observe that burning of magnesium ribbon is a chemical change, okay. What are the materials needed? Magnesium ribbon, a holder and a burner. Now what is a magnesium ribbon? Magnesium ribbon is actually a strip of magnesium wire, okay. So that when you burn, what happens? You have to see that. Now this, if the school was open, then I actually wanted to show you this in the lab, okay, but since the school is not open now, so I will give you a YouTube video. You can go through the activity, okay. So get a small piece of a thin strip of the ribbon of magnesium. So this you write in your copy, okay, all of you. So you get a small piece of a thin strip of a ribbon of magnesium, clean its tip with sandpaper. Now what is sandpaper? Sandpaper is the rough paper, okay, it is the rough paper which is used to clean the tips of metals or to clean any surface of metals, okay. So I think you must have seen sandpaper, the rough paper which you use to clean the table and all. When it becomes very rough, to make it smooth, you use it over the tables and all. That is sandpaper. Now bring the tip near the candle flame. So you take a candle or a burner and you bring the tip of the magnesium wire near the candle flame. Okay, that means you have to burn the magnesium wire or magnesium ribbon. So you should not hold the magnesium ribbon with your hand. Why you should not hold it with your hand? Because if you hold it with your hand, it is a metal, so it will become hot, okay, and your hand might get burned. So that is why always you need a holder for holding the magnesium ribbon. So that is why this holder is there, okay. Then what will you observe? You will observe that the magnesium burns with a brilliant white light. Okay, it will burn with a brilliant white flame. Okay, a white flame will come out once you put the tip of the magnesium ribbon into the candle flame. When it is burnt completely, it leaves behind a powdery ash. So after burning of the magnesium ribbon, what will be left behind? Powdery ash is going to left behind. So what is the equation? You write this also in your copy. You have it in your textbook also. Magnesium plus oxygen. Why oxygen? Because remember, whenever anything is getting burnt, always oxygen has to be involved. That process is called combustion. Okay, so what is combustion? When something is burnt, always oxygen is involved. Without the presence of oxygen, nothing can burn. So that process is called combustion. So whenever you are burning magnesium, what is happening? Magnesium is coming in contact with oxygen. Okay, and what is formed? Magnesium oxide is formed, MgO. Now here oxygen, the 2 has to be down, okay, because this is a PowerPoint presentation. I am not able to write it this way, but the 2 has to be down here. Now collect the ash. What ash you are going to collect? The magnesium oxide. Collect the ash and mix it with a small amount of water. So you take the ash and you mix the ash with a small amount of water. Stir the mixture well. Now the ash is not going to get dissolved, okay, but the ash will mix properly when you stir it well, okay. And then you need to test that solution. That means the ash plus water with blue and red litmus paper. Now what is the ash? Magnesium oxide, okay. So whenever you burn the magnesium ribbon, whatever is collected below, that is magnesium oxide, and that is the ash, okay. Now on dissolving the ash in water, that means when you dissolve the magnesium oxide in water, it forms a new substance, okay. So what is the new substance? I am giving you the equation here. Is given in the book also. Magnesium oxide plus water is what? Magnesium hydroxide, MgOH2. Now here water, this 2 has to be down, okay. So this is magnesium hydroxide. The magnesium hydroxide formed is a base. Now magnesium oxide is also a base, magnesium hydroxide is also a base. Now one very simple way to find out, just by looking at the formula, you can say maximum bases. I am not saying all bases, okay. Maximum bases, they have this OH group, MgOH2. You can see here OH is together. So you might be asking me now, if magnesium oxide is a base, here we don't have OH. Yes, we don't have. I am saying not all bases, but maximum bases, they have OH group in them. Okay, now whenever there is the OH group here, you can say that it is magnesium hydroxide. Okay, I mean it is a base. Similarly, calcium hydroxide will be CaOH2. You can see the formula in Google. You can just type calcium hydroxide formula. You will find the formula to be CaOH2. Sodium hydroxide, it is NaOH. Okay, NaOH. Now this OH group, whenever it is there, it has to be a base. Even if the OH group is not there in some, still it will be base. Like magnesium oxide is also a base. But if the OH group is there, mandatory it has to be a base. Okay. Now MgOH2, this 2 has to be down. Okay, like H2, 2 is down because this is a PowerPoint. No, I am not able to write the 2 down. Okay. So magnesium oxide is a new substance formed on burning of magnesium, isn't it? So when you burn magnesium and oxygen, you get magnesium oxide. And this magnesium oxide, when you mix in water, that you get to be magnesium hydroxide. Now both magnesium oxide and magnesium hydroxides are new substances. They have different chemical properties. Can you get back the magnesium ribbon again from magnesium oxide and hydroxide? No, you cannot get it back again. So this is a chemical change. Okay, why it is not a physical change? Because if it was physical change, it should be reversible. Okay, or a new substance is not formed whenever there is a physical change. But since it is not a physical change, it should be a chemical change, and because there is a new substance formed, so it is a chemical change. Now since it is a base, definitely you know it will turn red litmus blue, isn't it? Bases, they show this reaction, they turn red litmus blue. Now what is the conclusion? Thus we can conclude that burning of magnesium ribbon is a chemical change. Now this is how the magnesium ribbon is going to burn. Okay, can you see this? It burns with a brilliant white light. This is the white light that is given out once you put the magnesium ribbon in the candle flame. Now suppose this is the burner or the candle, this is the magnesium ribbon, you put it on the candle flame or the burner. Can you see this powder like thing collecting here? Okay, white powder, this is magnesium oxide or ash. Okay, white powder is MgO, it is written here, MgO is magnesium oxide. Okay, and this is the china dish. Basically in lab you have, I will take you to the lab whenever the school reopens. Also I can take you later, also I'll show you that this china dish is basically used in the lab. It is used to mix different reagents or chemicals. Okay, so you can take a china dish or a beaker, and when you burn the magnesium ribbon, this ash is going to collect here below. Okay, so this ash is magnesium oxide, and when you mix this ash with water, when you mix this ash in water, you will get magnesium hydroxide, that is MgOH2. Okay, and this magnesium oxide is also a base, and magnesium hydroxide is also a base. Okay, I hope I am clear. So we'll continue with the explanation in the next slides. Thank you.